Hello and welcome. This is T-Minus Today. My name is Dave, and today we're going to be talking about how 5G technology is going to impact the IT industry. Now, I'm from an enterprise side working in the data center for the last 10 years or so this is going to be skewed in that direction, kind of showing where it's coming from there. But I just want to talk about the 5G technology in general and how it differs from the previous generations. So, first there was nothing. Then there was 1G, and 1G was your basic voice communication over a wireless signal, and that was awesome, analog, right? Then 2G came out, gave you messages and your basic email functionality. Now 2G was around, I think, 2008. That's when the first iPhone came out, and the first iPhone was not actually 3G capable. It was 2G capable, and then the iPhone 3G came out, giving you that additional access to web technologies. Got your streaming, have your internet, and then technology continued to progress, and then you got your HD streaming, your video chats, and all the things that we enjoy today. And now 5G is coming out. You're getting much faster speed, you're getting reduced latency, much lower latency than you're getting with 4G, and it's completely changed how we use the internet. That doesn't mean to say that 5G is going to replace 4G, not in the slightest. It's actually going to be used in conjunction with 3G and 4G. These are different technologies at different wavelengths, and we're going to get into what the differences are, but first let's kind of break down 5G. Now there's a little circular graph here. We'll kind of just go through it a little bit. The latency factor, down to 10 or even 5 milliseconds of latency. That is much, much lower than 4G. The data volume is heavily increased, the peak data rate's increased, so everything is faster. And this is a cool part about it, a guaranteed user data rate of 50 megabits per second. You can have 20 billion human-oriented terminals. It's capable of connecting around 1 trillion things. Now that could be a sensor, an actuator, something in a car, whatever it may be, a refrigerator, something that's connected to the internet. It's very reliable, good, it's accurate to about 300 miles per hour, or just over 300 miles per hour, or 500 kilometers per hour, and it's accurate down to about 1 meter. It's very, very good. And it's easier to deploy, it's more energy efficient, everything about it is better. It's just an upgrade. So this graph is actually something I pulled from Verizon's website. It shows you how 1G is very slow, 2G is faster, 3G is even faster, 4G, you're continuing to scale, and 5G is just so much faster than any other network. And the reason for that is because 5G operates at a higher frequency. So 5G in general operates between 6 gigahertz and 300 gigahertz. As you scale up the gigahertz, your range decreases, but your speed increases. So you may notice in your house, you have 2.4 and 5G networks. You may have both of those if you have like a wireless connection. 2.4G actually goes further than your 5G connection, but your 5G connection is faster. So same principle here. So your 3G, that's anything that's running sub 6 gigahertz, is going to be much slower than something running at 39 gigahertz or 300 gigahertz. So as you scale up that frequency, your speed is also going to increase. But what you sacrifice here is range. And we'll talk about that a little bit further down the line. So we've been promised that science fiction is going to come to life with 5G. And 5G really is going to enable billions of devices, up to 1 trillion devices, to connect to the internet at the same time. That is an insane amount of devices. Now this, flying autonomous drones, driverless cars, we've already seen some of these, machine-to-machine interactions, so you could have a wireless facility, all these machines working together. Think of like an Amazon warehouse maybe, where there's robots going all over the place. They're all connected wirelessly, and they're communicating with each other at maybe 5 to 10 milliseconds worth of latency. That's going to be something we're going to see more often. And the cool thing about technologies like this that are so disruptive is that I don't really know what the future is going to bring. It's just hasn't been created yet. So the possibilities are endless, and we'll see what happens. Another thing that's going to happen is a change in the industry. And this is a cool graph here. Over the next 5 years, according to Cisco, the global IP traffic is going to change. A PC is the global IP traffic of PCs, is the green, and then that orange is going to be the mobile traffic. It's going to be inversed from what it is from back in 2018. So back in 2018, PCs accounted for most of the global IP traffic. And then by 2022, according to Cisco, by a study done by them, mobile devices are going to take over that mobile traffic, and PCs are going to kind of take a backseat for that. And that is unsurprising, or it shouldn't be that surprising. We have a lot of, whether it be a tablet or a phone, we're just connecting to the internet more and more with these powerful devices. And there's a huge push by a lot of corporate entities and companies to push 5G. Dell's really excited about 5G. AT&T is really excited about 5G. All these big players that have like back-end infrastructure are all very excited about 5G, because as you increase those speeds, your core is going to have to be replaced. So whether you're Cisco or Brocade or anybody that manufactures switches or just hardware, you're going to be happy, because you're going to need to have a massive build out of infrastructure to accommodate for all of this speed. So we are massively stepping up the speed and how it's being collected with all the devices that we're going to be throwing out there. All these mobile devices, these edge devices, we call them. So like a driverless car would be an edge device, or any sort of handheld mobile device that we have. Those are all going to be edge devices. And there's going to be a lot of build out for that. And there's a lot of money to be made by a lot of big companies. So all the big companies are pushing this as hard as they can, because they can sell so much and make so much money with this. But it's not a bad thing. Upgrading your backend infrastructure is never a bad thing. Being able to move that data quickly is very important. So you have your highway analogy right here. On the left, you have cars maybe filtering through one lane. It's very hard. Stuff gets backed up. But if you have multiple lanes, make that pipe just much, much bigger. Whether it be a fire hose that's much bigger than a normal hose, or however you want to think about it. 5G just allows you to push more traffic through it than anyone else. And what does this mean for consumers? So combined with that low latency and this high bandwidth network, it's going to allow for faster upload speeds, faster download speeds, streaming in 4K, seamless VR experiences. All this stuff is going to be happening at one time. My kids just interrupted me. Dear Dad, good morning. How are you today? Oh, and I got a piece of gum. Thanks, Kyla. Thanks, Bree. So the latency piece, it really cannot be understated. Current 4G networks display latency of roughly from 30 to about 150 milliseconds of latency. 150 milliseconds of latency is a lot of latency. The average person can detect latency down to about 80 milliseconds, they say. I am pretty sensitive to latency. I have a high refresh rate monitor, and whenever latency spikes by about 30, I can feel like a 30 milliseconds worth of latency there. So 5G should expect latency to eventually drop down to about 10 milliseconds, or even below 10 milliseconds, down to that maybe 5 milliseconds mark. That's kind of what we're shooting for. Probably not going to get there in the near term, but we're working on it. The last thing I wanted to really touch on is the edge. Now, I talked about the edge a little bit earlier, and 25% of all data volume will be real-time in nature and generated at the edge. So the edge can mean quite a few things depending on where you are in the industry and which side of it you're talking about. The edge can be mobile devices, can be end user devices sitting at the edge. You could have edge devices from a data center perspective, edge networks, edge infrastructure that actually takes data, like it goes up to the cell tower. You have your phone, it transmits up to the cell tower. That would be considered the edge of maybe a data center, where they'd have some equipment there, process data from your device, at the cell tower and then beam it back. That's how you're going to get the super, super low latency. They're going to be processing data at the edge versus going to the edge and then through the core to the cloud to someone's server and back to your phone. They'll process it just at the edge and then come right back. And that's going to make things much, much quicker. So edge compute market is expected to grow by 30% by 2022. That's already becoming a very apparent step in the industry that I'm in. So that's happening a lot. And because the edge market is growing so much, when we're creating our smart factories or our smart cities or any other smart thing, your autonomous vehicles, it's going to be generating a lot of data at the edge, whether it be an edge device or the edge of the core. And you're going to be maybe chattering between vehicles using that edge connection, and you won't ever go back to the core. And that's going to be something that's going to be required for super low latency networks. And that's going to be really interesting to watch unfold. So how will 5G impact the IT industry? Well, 5G is about distributing compute closer to users and devices. It's about building out that edge network and giving us real-time feedback. It's going to be your low latency, high bandwidth network at the edge, whether it be an edge device or an edge network. And companies really do need to prepare for this as 5G comes online and you've got all these sensors, all these actuators, all these cars, all these devices feeding data. It's going to generate way more data than we've ever experienced ever before. And it's just going to get bigger and bigger and bigger. But there are some problems with 5G, and I do want to talk about that. So 5G has a lot of issues. One of the things is it's cost prohibitive. A 5G sensor, you might have to have it in every street light because it only goes 100 meters. So implementing 5G in cities that aren't very dense or populated is going to be a very difficult task, and it's probably not going to happen for quite some time. So it can the range can be as low as 2 meters indoors or 300 meters outdoors. When it's raining, you get signal loss. If there's leaves blowing in the wind or other obstructions, you're going to have signal loss with this very, very high frequency connection that you have. So what's going to happen is that when you have a 5G connection, you're probably going to connect to more than one tower at the same time. And you're going to be doing kind of what Tarzan does as he swings through the trees. He's going to be connecting to one, he's going to be going through it, then you'll connect to another one, whichever one's closer, giving you the best signal. And you could have 3 or 4 or 5 or 6 of these, kind of like as you're swinging through the concrete jungle as you're driving through the city, staying connected to these devices. So that's how you're going to stay connected to 5G. So if there's an issue with a signal, it'll simply swap over to another signal that's stronger. And there's going to be a huge lack of widespread coverage for a long time. 5G coverage is super limited right now. Very specific cities have it. You can go look up what cities do have it. I was in Boston. Boston had 5G. 5G only went about 110 to 120 megabits per second, according to my iPhone 11 XR when I ran the test there. So it still has a ways to go. The Environmental Health Trust contends that 5G will require the build out of literally hundreds of thousands of new wireless antennas in neighborhoods, cities, and towns. A cellular small cell or another transmitter will be placed every 2 to 10 homes, according to estimates. So that's the Environmental Health Trust. They're just saying that we're going to have to build out. The infrastructure cost is going to be massive. Instead of just throwing up a tower here and there, you're literally going to have to install these every 2 to 10 homes, depending on the power you put behind these signals and what frequency you're running at. Another issue that comes is potential health issues. Radio frequency radiation, or RFR, is a concern that a lot of people have. From the data, scientists say that the most important criteria about whether any particular RFR is dangerous is whether it's ionizing or non-ionizing radiation. Some people say that it doesn't pose a threat. So non-ionizing radiation is too weak to break chemical bonds, but it still can damage tissue. A microwave can damage tissue, for example. and the FDA states that you shouldn't stand directly in front of a microwave when it's running. So there is that. There's really no clear-cut answer here because there's no known mechanism for non-ionizing radiation to have a biological effect on humans. It doesn't necessarily mean that it's safe. We've used a lot of substances in the past that we've just used for a while until we realized, oh wow, that causes cancer or something. So some speculation is that it is cancerous or maybe even carcinogenic. The National Toxicology Program, or NTP, is an agency run by the Department of Health and Human Services. They had a widely quoted study about cell phone RFR, or radio frequency radiation. They found some evidence that high exposure to 3G RFR led to some cases of cancerous heart tumors and brain tumors and tumors in the adrenal glands of male rats. So there is that. So there are studies there by the National Toxicology Program that have shown cancer showing up when we're using 3G. It's also good to note that the FDA also doesn't want you to put your cell phone directly against your ear. You're supposed to hold it a little bit away from your ear, probably for something like that. In 2011, the World Health Organization also weighed in, classifying RF radiation as a group 2B agent, which is defined as possibly carcinogenic to humans. So there's been a call by groups of individuals. More prominent Senator Richard Blumenthal, a Democrat, he raised concern that there's really no scientific research when it comes to 5G technology, and the FCC should go do more research to adequately explain how we've determined that 5G is completely safe for humans. So that's something that we definitely need to take into account. No, 5G is not the cause for this global pandemic that we have, but more studies are never a bad thing, and learning whether it's possibly carcinogenic or the cause of cancer would be a really good thing to know. So being able to have those out of the way and have some concrete data there would be really, really nice. There's not a lot of long-term studies that determine this, and then that's going to come as we implement 5G. It's going to be a slow roll anyway. So 5G, because we have hundreds of thousands of these to install, it's going to take a really long time for us to implement 5G everywhere. Eventually, it's just going to be pieces of 3G, 4G, 5G like we have now. It's just going to be lots of technologies combined together to create this wonderful world that we live in. That's some of my thoughts on 5G technology, where we are, where we're headed, and I'm excited for the future. There's a lot of really cool things coming out due to 5G, and I'm excited to see what developers can dream up. Well, that wraps it up. Go ahead and like, subscribe, or hit that notification button if you want to know when I'm going to be posting these, and I will see you in the next one.